Why train models from scratch when you can leverage pre-trained models? Learn how to save time, boost accuracy, and build smarter AI systems with transfer learning. By the end of this tutorial, you will learn everything you need to know about transfer learning and also learn how to implement transfer learning using the TensorFlow framework. This tutorial is going to be fast, practical, and beginner friendly. If you are new here, consider subscribing so that you don't miss any of my future tutorial. So the first question every beginner will ask is, what is transfer learning? Transfer learning is a machine learning technique where a model trained on one task is repurposed for a related task. So if you want to train a model for a specific task, let's say a computer vision task in this case, you don't have to start from scratch. You can leverage on pre-trained models and build your model on those pre-trained models which have been trained on a lot of computer vision related tasks. So the key idea behind transfer learning is that it uses knowledge from the source domain, in this case the pre-trained model, to improve learning in a target domain. So the target domain in this case is the new model you are trying to train. And why is transfer learning? Okay, transfer learning is very important because one, transfer learning can reduce training time by using pre-trained models instead of you training from scratch. So if you don't want to waste a lot of computational resources, you can use transfer learning, and that's going to decrease your model training time drastically. Transfer learning can also improve model performance by leveraging pre-trained knowledge. So the pre-trained models you are going to use have already been trained and they've learned important features from data. So leveraging that pre-trained model will just help improve your new model. Transfer learning can also reduce costs by avoiding the need to train model from scratch. Transfer learning can also help prevent overfitting, which occurs when a model fits too closely to its training data. So overfitting occurs when the model works or generalizes well on the training data and cannot function well in a real-world scenario. So in that case, when you use transfer learning, it can help improve that and prevent overfitting. What are some of the applications of transfer learning? So transfer learning can be applied in image classification, where you can use pre-trained models like ResNet, VGG, or EfficientNet. Transfer learning can also be used in natural language processing, where you can fine-tune the BERT model, GPT, or T5 model for text classification or summarization. Transfer learning can also be used in speech recognition. Finally, transfer learning can be used in medical imaging. So as a beginner, one question you also ask is, when should I use transfer learning? Okay, so you should use transfer learning when you have limited data in the target domain. So let's say you want to train a model to detect diseases, but you have only few images. You have about only 100 images. You can use transfer learning, but make sure the particular pre-trained model you are going to use is related to the task you want to solve. You can also use transfer learning when the source and the target domain tasks are similar. So as I said earlier, if you are going to train a model to solve a computer vision task, you must make sure you choose a pre-trained model that is related to computer vision. There is a little bit of caution when you are using transfer learning. If the source and target tasks are too different, transfer learning might not help, and that is termed as negative transfer. So if you are solving a problem related to computer vision, you must make sure you use a pre-trained model related to computer vision. Now let's look at some popular pre-trained models. In the case of computer vision, we have VGG, ResNet, Inception, and EfficientNet. For NLP, which is natural language processing, we have BERT, GPT, T5, and RO-BERT-A. For speech, we have Wave 2 to VEC and Deep Speech. For reinforcement learning, we have Alpha Zero style pre-training. So now let's actually look at how transfer learning really works. From this diagram, you can see we have two sessions. So the source model and the target model. So the source model here is the pre-trained model we are trying to use to do our transfer learning. And from this pre-trained model, you can see we have different layers. Okay, we have three different convolutional layers. So we have the source model, and all you are trying to do is to remove the prediction layer. Okay, so normally these layers are the layers responsible for predicting the outputs. So these dense layers are responsible for the prediction. So what you are trying to do is to detect this dense layer and attach your model to the end. And in that case, your model you are coming to train will benefit automatically from all these layers in the source model. except that you are detaching these final layers and attaching your model. You can see how the target model will look like. We've inherited all these layers and now we've attached our new dense layers to it. So this is our new dense layer which is going to predict for us, and in our case it's only two classes, so binary classes. Okay, so you can see how powerful transfer learning is. You are using all the knowledge stored in these particular layers and you are just attaching your model, so automatically your model benefits from all the knowledge base in this particular convolutional layers. And also one thing to note is that you have to freeze all these layers because they have been trained already. Okay, so all you need to do is to train this your additional layer attached to these convolutional layers. So that's how powerful transfer learning is, and this is how transfer learning works. So all you are trying to do is to take the source model, cut off the prediction part of it, and then attach your model to that end. That's all you are trying to do, and that's what transfer learning is all about. Now let's look at how we can implement transfer learning using TensorFlow. Alright guys, so I'll be using Google Colab for this particular code so that you guys can get access to this particular notebook. So if you want this notebook, just check the video description and the link to this notebook will be right there. In Google Colab, I've made some couple of imports. Most of these packages come pre-installed in Google Colab, so you don't need to reinstall anything at all. So I've made some couple of imports from TensorFlow and also imported OPCV, NumPy. From sklearn, I've also imported train test split. So all these imports are necessary for us to complete our transfer learning tasks. The images I'll be using are from my Google Drive. So when you check over here, you can see I've mounted my Google Drive, and inside my Google Drive, I have a folder containing images of cat and dog. When I open that folder, you can see over here we have cats and dog. So if I open cats here, you can see we have images of cats, and over here we also have images of dog. So feel free to use any images you have, or you can even use the MNIST dataset. You can import that from TensorFlow to practice with, but I'm using real images I have on my Google Drive. Okay, so this code right here is to load these images and pre-process them. Okay, so I'll go ahead and just run this cell to make all the necessary imports. I also come here and run this one that will load the images from my Google Drive and process them and normalize them and also split them into train, test, and validation sets. So you can see right here that the number of images are 348, and I have resized this image to 244 by 244, and the 3 here is the color channel. 348 here is the total number of images we have. So make sure you resize it according to the shape of the image your pre-trained model accepts. So that's very necessary. I found out that most of the pre-trained models use 224 by 224 and 3 color channels. So I've resized my images to that exact shape. So I've divided the images into this particular set. So you can see the train sets have 243 images, validation sets have 52 images, and the test set have 53 images as well. So you can feel free to partition it. I've used the sklearn train test split to split these images into these various categories. Moving on, I've imported most of the pre-trained models. Okay, so you can see I've imported VGG16, VGG19. So all of these are pre-trained models, but I'll be using only one. I'll be using VGG16. You can go ahead and try or test any of them. So to import them, you use from tensorflow.keras.applications. You import all these models from there. So I've imported a lot of them, but I will be using one as I said earlier. So let me go ahead and run this cell, and this will import all of them. So the one I'll be using is the one I'm choosing here. So I name it base model. The variable name is base model, and base model is equal to VGG16. In case you want to use VGG19, just copy it and do base model is equal to VGG19. But I'll be using VGG16. So let's run this and also print the architecture of the model and see how this pre-trained model looks like. So it will download the model and then display how the architecture looks like. Alright, so this is the VGG16 model, and over here you can see it has so many layers. Okay, and also the input shape. So this is the input shape of the image. Okay, so you can see it's 224 by 3. So you have to make sure you resize your images to this exact shape. From there, you can see we have the total trainable parameters to be 138 million plus. Also, the trainable parameters is 138 million plus, and the non-trainable parameters is none. That means all these parameters are trainable. But as we already know, this model is a pre-trained model, that means it has been trained already. So from here we have to build our own model. So our own model, we say our model here is equal to sequential. So we have to loop through the base model and also detach the last layer from it, because I told you the whole idea about transfer learning is that you take a pre-trained model, detach the prediction layer and attach your model. So over here we have our model and we are looping through all the layers in the pre-trained model, and these are the layers as I showed you over here. So all these ones here are the layers. So I'm looping through all of them and then I'm slicing. So what I'm doing here is that I'm taking all the layers except this last prediction layer. Okay, so I'm excluding that prediction layer. If you want to exclude more layers, you can go ahead and exclude all of these layers by just putting the appropriate number here. So -1 here means I'm taking all except the last one, and then from there I'm attaching my model to it. So I'll take all up to here, and then from here moving on, I'll just attach my model to it. So that's why we do model.add, and then we add these layers to our model. From there I've printed the architecture once again so that you can see how it looks from here. So I'll just scroll down and you can see now we've detached the last prediction layer and we have attached that to our model. So once we have attached that, now we can move on with our model. So I told you also in the slide that we have to freeze all the layers. Okay, we have to freeze all the trainable layers because it's a pre-trained model. We don't want to retrain that model from scratch. So what we'll do is that we still loop through all the layers of the model, and what we do is layer.trainable equals false. Okay, so we want to freeze all of those layers that have been trained already. So after freezing them, I still print the model.summary, and then over here now you will see that the total parameters is 134 million plus, but trainable parameters is 0. We don't want to train any of these layers again. So we've set layer.trainable equals false. So now that we've set all these layers to false, it's time to add our own layers that we want it to train. So that's why we add our own layers for the binary classification here, and you can see we have model.add, and then we flatten everything so that we'll get our one-dimensional array. And over here I've added a model.dense and added unit is equal to 1 because we are doing binary classification, and the activation function I'm using right here is sigmoid. Okay, so sigmoid is either 0 or 1. Sigmoid is used for binary classification. Then I have done model.summary once again so that we'll look at our new model architecture. So over here now you can see how it works. The total parameters is 134 million plus, and the trainable parameters is only 4099. So you can see we have turn all those layers to non-trainable parameters, and now we are coming to train only the layers we've attached to the model. So we have attached one flattened layer and one dense layer. So these are the layers which have contributed to the trainable parameters being 4099. From here, you can also see the non-trainable parameters now is very high because we are only training these parameters. From here, you can just compile the model and also define a callback function and train the model. So I'll quickly go ahead and run all these cells and let's see the training process in action. So I'll run it from here to import all these pre-trained model. So connect, let me connect with our TPU. Okay, so let me run this once again. From here, we'll also run this. I'll run all of these to also freeze all the layers we don't want to train. So now we just compile and start training. So I'll run this, and if everything works, you can see our training process will just kick in. And here we go, guys. So you can see our training process have kicked in and we are running 1 out of 10 epochs. So I'm not just going to allow this to finish training. The whole purpose of this tutorial is to show you how this is done and also give you access to this code so that you can modify it and do transfer learning on your own. So it's working and I'm very glad that it's working. So let me know what you guys think in the comment section. Also, as I said earlier, the link to this particular notebook will be in the video description, so check it out and try this on your own. Thanks for watching, and I will see you in the next tutorial.